I don't know. Kind of sounds like a personal problem.
It is. I feel like an idiot. I'm over here with the cursor. First world problems, right?
Yeah, don't you hate it when it's early in the morning and you can't resize your dog?
Oh, poor little duck.
Yeah, that's it.
Okay, Jason, since you're here and it's starting to generate some messages on Discord, we must have a sad plant update.
Oh, so there was an incident.
Oh, no.
Oh, no.
Yeah, so what happened was that plant got in the direct sunlight a little too much.
Oh, no.
That plant had an incident.
Sad plant is even sadder than it was before.
Yeah, I'm waiting to see how much the sad plant dies and how much still survives.
Oh, no.
Dinah, it's touch and go right now with sad plant. So just hands off, just put him under. He's in the shade.
I think sad plant's kind of taken off, so you may need a webcast dedicated to sad plant.
It's true. We'll see what happens. With I was thinking about just doing a pre-show banter webcast sometime soon.
Yeah.
Pre-show banter.
Webcast is nothing but pre-show banter?
Yeah, that's it. And it's just
I love it. That's great.
pre-show banter.
Yeah, just title the webcast random stuff and we're set to go.
There's the Ask Me Anything that people do, but we'll just call ours just random nonsense.
Yeah, and let everybody speak. That'd be awesome.
Although it's kind of funny, the pre-show banter reminds me of the old days at Sands when we used to have contests to see who could go through the most number of slides without actually talking about any of the slide content and not getting called out on that fact by one of the students. Yeah. And I seem to remember Stephen Northcutt had the record for that, and it was like 47 slides or something like that. Because it just kind of go into so back when I used to work at a nuclear bunker, and there'd be slides on firewalls, and it just, change a slide every couple of minutes.
That's great.
I think that's really the key. So long as you have an interesting enough story, it can have nothing to do with the slides, and that's okay.
Yeah.
By the way, I don't know about you guys, but I'm eternally grateful for everyone that's here. Whenever we do a webcast and we say that we're going to talk about our commercial product and people still show up, really appreciate that, you all. We're not good at this whole product thing and doing it like everyone else does. And I think that that's a good thing at the end of the day. But we are eternally grateful that you're here. And I guarantee you're going to get an amazing amount of free stuff as well, because there's so much free stuff that we're doing that many people aren't aware of yet that will help their security programs. So, Chris, are you ready to rock it?
I am totally.
All right,
Awesome.
kick out the
Totally. Cool. And I am going to drop my screen share so it's a little bit easier to see what's going on. So stop sharing the webcam. Nobody needs to look at me today.
Thank you, Chris.
There we go. Awesome. So what we're going to cover today, as John said, want to talk a bit about our commercial tools. A little bit of a caveat of that, like John said, we're not very good at it. But really, the reason I kind of wanted to jump into that is we've talked a lot about threat hunting as a process and what are the steps to go through. And I wanted to kind of leverage our tools to kind of drive that home. Because a lot of folks look at it and it's, I don't know, it kind of disconnects until you actually see it in action. And I think our tool does a really good job of that. I also think that the way we go about threat hunting has been really kind of disruptive. Folks are kind of used to I send all my logs to Splunk, write a couple of scripts, and hopefully catch stuff. And we don't do stuff that way. So I really wanted to kind of be able to go through and kind of drive all of that home. So threat hunting is a process. We talked about this in a number of different webcasts. The reason we need threat hunting is that when you look at security today, the one place we're failing horribly is detection of adversaries once they get into our network. Once an adversary is able to get past our protections and get a beachhead on our network, it's 6 months or more on average within the industry before they get detected. And further, when they get detected, a majority of the time it's by an outside third party. It's not even by the company that got, or the organization that got compromised. Reducing that time between when our protections fail and we've realized we need to go into response mode, that's what threat hunting is all about. And we've talked a lot about the process. Threat hunting, there's a lot of talk about, what is it? What does it mean? The description's pretty straightforward. Threat hunting is validating every single internal system, not just your desktops, but the routers, the industrial Internet of Things devices, everything. It's identifying it's looking at everything on the network and coming up with, this says one of three dispositions, but really you're looking for one of two. And the two dispositions are, I'm pretty certain that system is still in a clean state. I'm pretty certain that system is okay. Or I'm pretty certain that system's been compromised. We need to go in an incident handling mode. The third state that's listed here is just simply, you're not sure. But if you're not sure, you need to figure out how to get additional information to go back to one of those first two dispositions. So at the end of the day, threat hunting is a validation of the network. You're going through and you're doing a validation to identify, are any of my systems in a compromised state? So this order that we keep talking about, when you think about, you've got hundreds of thousands, millions, whatever connections taking place across your internet link each day, you need to prioritize things. You need to figure out, what's the first check I can do that's going to remove the greatest number of systems from potentially needing additional investigation work? Then what's the second thing I can do to go through and remove the greatest number of systems that might potentially need additional investigation work? If you kind of think about it, imagine I have 100 systems. I'd love to have my first check go through and say, hey, these 80 systems, don't worry about them. You're down to just these 20. And now my second check says, hey, these 18 systems, they're fine. Now you're just down to 2. You want your checks to kind of run in an order that eliminates all the possibilities as quickly as possible. And that's really what we've come up with here. So the first check is persistent connections. Is there a connection between your internal system and a host on the internet that looks programmatic that's taking place 24 hours a day? If so, that's worth investigating. If not, don't bother. And that very quickly eliminates a lot of the sessions we might need to go in and analyze. Next, go in and look at the protocol behavior. Was somebody bending or breaking the protocol rules? If so, oh yeah, that's definitely worth going in and taking a look at. When you're browsing the web, Chrome or Explorer or whatever isn't going to start running an SSH session over the HTTPS port, over TCP 443. It isn't going to do that. So if you see SSH traffic going across that port, somebody's up to some shenanigans. Somebody's up to no good. It's worth taking a look at. So again, protocol behavior next, then go in, look at the reputation of your endpoints. It could be external or internal first, depends on what you have the most data to work with. And that's when you go through and you decide to go through and do your disposition. Or maybe you get to that point, you say, I'm still not sure. Okay, now maybe we got to pivot into host logs and go in and kind of run it down from there. That whole threat hunting process, yeah, I just hit over it briefly. If you want to jump into greater detail on that, John is teaching a class in August that's going to be a one-day. Here's kind of the 101 on threat hunting, get your feet wet, get started on that whole thing. Also in August, I'm going to be a 2-day. Okay, if you've gone through our 1-day class and you want to keep doing it and doing more, here's a 2-day class you can go through as well. That'll get posted up to the Wild West Hack and Fest site in the near future. The first threat hunting tool we came up with was RITA. And RITA is pretty cool. Not the least of which is this is an open source tool. This is freaking amazing. I'll be honest, when you're in looking for C2 channels, there's not a lot of commercial tools that can do a better job of that than RITA. RITA is just really good at kind of picking out where do you have a command and control channel taking place, and we make it available for free. It has a lot of different functionality to it, like the ability to go in and go looking for beacons. We have a scoring system within the beacon stuff itself. That's just to kind of help you, I don't want to say that, it helps you prioritize things. Because a beacon is still kind of a subjective term in that just because something's beaconing doesn't necessarily mean it's bad. So we've got a score system built into that to kind of help drive you to figure out which ones do you need to go in and kind of take a look at first. So that's built right into the tool. And you can set this up so that RITA goes through your data once a day, multiple times a day, whatever it is you want to do, to go in and start looking for suspicious patterns. You can also go looking for long connections. For anybody who's gone through our one-day threat hunting class, we have some labs that are based around doing RITA. These are actually directly out of that course material. So if you want to dive into this more, go in and kind of work with RITA. One of the things we do in the labs is we kind of start off doing this manually, meaning you start off using like T-Shark and you go in and start using like BroCut and stuff like that to see what does it take to go in and start looking for these persistent connections. And then we kind of upgrade to RITA to see that RITA will automate and scale an awful lot of those checks for us to make it even easier. AI Hunter, which we're going to look at in just a minute, kind of does the same thing on top of RITA, meaning it's kind of built to build and scale on this. But RITA is still a very manual tool. When does RITA make more sense versus AI Hunter? If you've got bandwidth, meaning like you've got free time and you've got some solid scripting capability, RITA is a great tool to go through and start checking for C2 on your network. If you have a larger environment that maybe is pressed for time, meaning you have a lot of security functions you're trying to get done on a daily basis, and you have junior analysts that you need to make more effective, AI Hunter might be a better way to go. And we'll look at that in just a minute. Again, RITA's here and it kind of runs through all that stuff. Now, especially for the folks that have gone through the RITA labs, I kind of wanted to walk through how AI Hunter deals with it. So, because RITA, like I said, you're processing a lot of data manually. You're writing scripts to go through and kind of parse it out. And really what we've done with AI Hunter is we've really tried to automate a lot of that. My big drive as product owner on this has been to make this as simple of a tool to use as possible. I really wanted to create a tool that, like, threat hunting pre-AI Hunter, even when RITA was around, was kind of, you've got to know what you're doing to get anything done. You've got to really know what you're doing to have any shot at catching the bad guys on the network. You've got to have an advanced skill set. And what we wanted to bring to the table was the ability that people who haven't built that advanced skill set yet actually have a chance of being able to catch the bad guys. And a lot of it comes out of this scoring system. So we do alerts a little bit differently than most tools. Here's an example. So this is a Slack channel. You can, syslog this to Splunk or whatever your log collection tool of choice is. But if you think about how our security alerts work, they tend to fall into one or two categories. They either go off all the time, which means we just learn to ignore them, or it's some convoluted alert that doesn't make a whole lot of sense. And unless we spend 15, 20 minutes on Google, we're never going to figure it out, in which case we probably won't do that, which means we might still miss something. One of the things that really bums me out is we have a lot of security vendors that will say, oh, that attack technique or that attack tool, yeah, we detect that. Oh, hey, lateral movement in the network, yeah, we detect that. We'll detect somebody running PowerShell to go through and try and do lateral movement on the network. And when you look at it from a purist perspective, they do. The problem is they false positive constantly, meaning that if I have an alert that's gone off 99 times and it's been a false positive, but then it actually detects lateral movement, is it any surprise I might ignore that? So along with making this simple, one of the things we wanted to do was reduce the chances of a false positive. We never wanted to be a tool that folks just ignore. So this is where alerting comes from. So the alerting, think of that as just a threat score. So this is us looking at the system saying, this is how suspicious the system looks for us. And we'll talk about what we kind of pull in and look at that in just a second. But notice this first log entry says, hey, you set a threshold of 90 threat points. Anything above that you want to see. And this thing just poked its head above it and it's at 94. And what I coach customers on is, if you see this, don't worry about it. If you've got free time and you want to look into it, great, go for that. But if you're not, or if you don't have the cycles, don't worry about this yet. What you're looking for is this pattern here. Notice every 2 hours, we're seeing that score jump up about another 15 to 25%. What AI Hunter does is it's hunting the previous 24 hours worth of data that's available. So we're always looking in the past 24 hours, and there's a lot of reasons for that, and I'll kind of get into those in just a minute. But we're always kind of looking towards the past. If you think about it, I've got a system that's clean and then it gets compromised. Well, in that first 2 hours, AI Hunter is going to have a little bit of data to work with, tell us it's compromised, but not a whole lot. Well, that's why the score jumped to 94. And then 2 hours later, it's got more data to work with to say, hey, I think that box has been compromised. That's why the score jumped up to 104. So if you see like 3 of these in a row, yeah, that's now worth going in and paying attention to. Oh, wait, but Chris, now you've waited 6 hours. Oh my God, that's the end of the world. No, it's not. Again, our industry average today is 6 months before we detect these things. People get like hyper caught up in, oh no, we have to detect everything in real time. I must see it in real time. Real time ain't working. 6 months isn't really working for most people. So if you can tag something in like a 2 to 4 hour, 2 to 6 hour period of time, oh my God, you were so much further ahead of the curve than everybody else.
And I think that whole idea is based on the premise that we can just do signature-based detection, that you can just basically detect this. And that was kind of the trap I think intrusion detection got us into with IDS sensors. It's like, or antivirus. Well, we find this signature, we detect it, and now we've detected the malware. And with real time, most of what we're discovering is that most of the malware we can actually start detecting in a 2-hour window. As soon as Bro rules its logs, we're actually picking it up on that specific within that 2-hour window. So it's not always the 24-hour window. It's basically kind of using that whole time frame as a baseline. So most of the time with most malware, and Keith can speak to this more than I can, as we're running malware through a thing we call malware of the day, even a 1 hour period is actually lighting up most malware very, very easily.
Yep. Yeah, it won't necessarily give it a high score after an hour, but yeah, absolutely you're going to see the score starting to go up. But again, so to kind of roll it back, so imagine I'm a junior analyst, I'm working a security operations center. Part of my job is to respond to things that might be in a compromised state. I see these alerts come in. What do? Well, the first thing I do is I log into the AI Hunter interface. On the left-hand side of the screen, that's all my internal IP addresses sorted by threat score, highest score at the top. So whatever system was just jacking up on the score, that's probably going to be the one on the top of the list. On the right-hand side, I have, this is where that score came from. So again, we're thinking kind of junior analyst level. How do we make them effective? It doesn't get much easier than this. Hey, you're seeing a system score going up exponentially. Okay, you need to pay attention to that. Now as I come in and I look at this and say, okay, why is this thing a problem? Well, if I just look at the points, there was 365 points assigned to this IP address. 272 of them was because of these text query count thing. What does that mean? Well, all of these are clickable. So I can just click in and go at it from there. And high text query count is an indication that this may be C2 over DNS. And one of the indicators of that is seeing a lot of fully qualified domain names resolved within a specific domain. So for the average network, you're going to see like 10 hosts or less. For the big folks out there like Microsoft, Akamai, Amazon, Google, you might see a couple hundred. Once you hit like 1,000, it kind of starts not making a whole lot of sense. If I look at my top line entry here, this says that our DNS server or servers resolved 62,000 plus unique fully qualified domain names within the domain r-1x.com. Okay, I've never heard of r-1x.com. I don't know who they are, and it makes absolutely no sense there would be 62,000 hosts resolved inside of it. That's what tells me that this might be one of the first things to tell me that this might be C2 over DNS. Now, again, go back to a junior analyst. How do we train them on this? Oh, that's easy. You take a screenshot of this, you draw a circle around this number, and you make a little note on here that says, if greater than 1,000, call a senior analyst. So now, tools going through doing that initial check, you can leverage junior analysts to go through and do the secondary. Now the senior people, the gurus, are only getting involved when they absolutely have to. Namely, we've got a system that's in a compromised state. We need to figure out how we're going to recover from this incident. That's when you definitely want the senior people getting involved. The other thing we go in and do a check for is just utilization. So if you look at akadns.net, we saw 125 hosts within that domain. Our these 3 DNS servers did all the lookups. And that resulted in 13 internal systems going out and connecting to akadns.net. Well, that makes sense, right? That's kind of how this works. We type a domain name in our browser. Our system then goes out and uses DNS to change that to an IP address, and then it connects to the IP address. So I would expect if I'm resolving names, I've got internal systems that actually need to go connect to those systems itself. So this is normal activity. Well, if I go back to that first entry again, I've got one system doing queries, and that's the only one that ever goes to that domain. Well, wait a minute. Why did I look up 62,000 different host names if nobody ever needs to go there? So that's another potential indicator of there being C2 over DNS. So again, circles and arrows, I can create a real easy run book for a junior person to go through to kind of figure out what's going on here. So if they go through that and say, hey, yeah, okay, we're onto something here, what do they do next? Well, next you go in and say, okay, so I know I got a problem here, but I'm also getting 93 points that are showing up as part of the beacon score. What does that mean? Well, let me just click on that. And I get a screen kind of similar to this. So this bottom graph to me is like worth its weight in gold. Because when you talk about beacons, people tend to kind of think quantity, right? They think about, oh, hey, if I see 20,000 connections coming from an internal system to a host on the internet in a day, that's probably a beacon. And the answer is maybe. If it's 20,000 connections in a minute and the rest of that 24 hours there's no activity, no, that's definitely not a beacon. But if it's 20,000 connections evenly spread out over a 24-hour period of time, yeah, that's going to be a beacon. So this graph down the bottom, my x-axis is time. Each one of these bars is a 1-hour period of time. I can change it if I want to, but the result is my y-axis is quantity. So this is telling me how many connections are taking place over whatever time interval I've specified for that full 24 hours. Anytime I can draw a flat line across the top here, that's a beacon. That's a repeating signal taking place. So that's something to go in and take a look for. Now, one of the things we do so when you look at how most tools deal with this, they use an algorithm called k-means clustering. K-MEANS space clustering. You can go check out the wiki if you want to see how it works. But really what k-means does is k-means is great for finding repeating patterns in a data set with a large chunk of data in it. So imagine I've got a ton of connections going back and forth across the internet, but I have an internal system connecting to an external system exactly once per minute all day long. That's a repeating pattern. So k-means is designed to extract that out, no problem. The problem with k-means is that all the cool kids today are using jitter. So what they will do is they will add a variable to their timing. So they may say, okay, I want to beacon once per minute, but rather than having it be exactly once per minute, I'm going to vary it plus or minus 50%. Well, that means that the time interval might be as short as 30 seconds, might be as long as 90 seconds. That's no longer a repeating pattern. So if you jitter a connection, anything relying on k-means clustering to try and detect beacons starts missing it. And I'll be honest, most of the tools out on the market today, that's what they use. So if you've got a tool like that you want to try and circumvent, just don't do even beaconing and you'll be able to get by. The other thing you might be able to do is just lengthen out the time interval a little bit. Most tools keep state for 2 to 3 minutes and that's it, meaning that if I'm beaconing once per minute or once every 2 minutes, they can't detect that beacon. They're not keeping enough of a time interval. That's one of the reasons why we're going in and grabbing 24 hours, because you can do a very slow beacon and you're still going to be able to go in and pick things up. The other thing it allows you to do is you can do some slick stuff like that jitter example I gave. Beacon once per minute plus or minus 50%. Well, you're still going to get about 60 beacons every hour. You're still going to get about 120 beacons every 2 hours. Well, that means if I take my 24 hours worth of data and I organize it into 2-hour chunks, if I can still draw a flat line across the top, oh yeah, it's a beacon. So you can still go in and detect stuff like that. We have, I think it's 24, 26 different patterns in the way we go about doing beacon detection. So what's different about the way we're doing it versus everybody else? That would be it in a nutshell. Again, step one is identifying persistency of connection. If you can't identify persistency of connection, the rest of this starts falling apart really fast. And that's one of the reasons why we've tried to make sure the tool's really good at that. We not only look at beacons based on timing, we also look at them based on session size. And again, this is kind of a unique identifier for us. You can imagine if I'm only keeping state for 2 minutes, I've got very few data sessions I'll see to start trying to compare their size to see if there's any patterns in that. Well, if I've got 24 hours worth of data, I can collect up all the sessions, all the connections from this internal host, that external host, and see, is there any consistency taking place in the session size? And typically when there is, the largest consistency, that's my heartbeat. That's my, do you have anything for me to do? No, go back to sleep. What's kind of cool is if that changes, if the compromised system ever calls home and says, do you have anything for me to do? And it's told yes, whatever it was told to do, that's going to result in a different amount of data being transferred as part of that session. That's kind of cool because that means we can easily go in here and we can detect, is it C2 yes or no? We can do that. But we can also detect, was it activated? Did they actually turn this on? Because if you can imagine, if somebody sets up a C2 channel to one of my systems and I can say definitively they didn't do anything with it, cleanup's fairly straightforward at that point. If, however, they got in and they transferred out a boatload of data and it looks like maybe they got our customer information, oh, my day just got a whole lot worse, right? I'm probably going to be forced to disclose that this thing took place. So one of the kind of cool things you can do is you can go in and you can see, was this thing activated, yes or no? And what we're seeing is, yeah, we had an activation that resulted in about 300 bytes worth of data that went by. Okay, what can you do in 300 bytes? Well, not a whole lot. You maybe see processes running in memory. You might be able to see like a directory listing. It's not a customer database. It's not all the Excel spreadsheets that are on the local system. So if I go in and see something like this, I know I'm still in pretty good shape. The other thing this helps you do is it helps you to detect when social media is being used as a C2 channel. I'll let you in on a dirty little industry secret. Most tools ignore command and control when it's run through Twitter, Gmail, Office 365, all of these social media tools. And there's a reason for that. Think about your Gmail tool, right? Your Gmail tool goes in and checks in for mail every 10 to 12 seconds or so. And it goes to say, hey, is there any mail? If I set up a C2 channel, I just have it check at that same time interval. And now if the only way I'm looking for beacons is based on timing, I now can't tell the difference between a user checking their email account and a compromised system using Gmail for its C2 channel. So what do you do? How do you kind of figure that stuff out? Well, the answer is it comes back again to session size. If you think about your average business user, they send and receive about 112 to 115 emails a day. So I'm part of the everyone group, I'm part of the security group, I get spam on occasion, and further, all those messages are different sizes because sometimes I'll get one line, sometimes it'll have attachments to it. So when I look at the distribution here, for a regular email user, I'm going to see the heartbeat, it checking in to check to see if there's mail and there isn't any. And then I'll see about 115 other peaks along the bottom of all those different email sizes. If this is C2, what I'm going to see is either just the heartbeat and that's it, if it was never activated in the course of that day, or I might see a couple of peaks along the bottom and that's it. You know, if the attacker went in and activated it 3 or 4 times, I'll go in and I'll see that. So if I look at how often was this channel activated, I can very quickly tell the difference between something that is just a regular email client versus something that's acting as C2. So again, that's kind of another differentiator for us. So being able to go in and kind of check these things on session size really becomes important to be able to go through and kind of tag this. All this is showing us is this is a beacon. It doesn't tell us, is it good or is it evil, right? This might be something that is okay, meaning that what if I've got a temperature sensor on my assembly line and it reports the temperature back to a central controller every 10 seconds? Well, that means every 10 seconds there's going to be a signal, and the signal size will be the same size every time because it's just sending a temperature. That's going to look like a beacon. So I could end up in checking for beacons. They're rare, but we do have business needs for them. I might run into a false positive. How do I deal with that? With our open source tool, it's a little bit of a pain. You know, you got to go through and kind of figure out how to not see that IP, those sessions anymore. We've made it real easy with AI Hunter. Every IP address has a little filter icon next to it. So if I look at this and I say, oh yeah, no, this is fine, don't worry about it, I can click that filter icon and that'll bring up my whitelisting screen. And I can go in and I can say any beacon going to that IP address, don't worry about it. Or anything going to that subnet, or anything going to all the DigitalOcean, or this ASN. I can also go in and I can do it based on pairs. I can go in and I can say only these two IP addresses. This is great for like remote access. A lot of times what you run into is when you go in and you do a C2 check on a network, one of the first things you usually run across is there's a lot more systems running remote control software than you expected to see. We've gone into environments where the customer has said, oh yeah, these two database servers, we've got a third party managing them. They'll have a remote access server on there. They'll have TeamViewer running or something like that. And then we go in, we do the hunt, we find 10 different systems that are running TeamViewer. Well, wait a minute, what's going on with those other 8? Okay, we got to run that down and figure that out. But if there's 2 systems that I know are okay, I can just go in and do a specific IP to IP whitelist on them. And now I don't see those 2, but I'll see anybody else that goes in and starts running TeamViewer. I can also go in and add comments to these. So I can go in and I can say, this is why this whitelist entry was created. Now, 6 months from now, when I'm looking at this whitelist entry saying, what's this? There's a comment there to kind of help me through that. And then once I apply that whitelist, that goes through and that just says, okay, so whatever you just whitelisted, we're not going to add threat points for that anymore. So that'll go in and kind of normalize out all of your scores. Give some other information, things like, what protocol is being used on that port. We talked about looking for protocol abnormalities. You can do that with AA Hunter. So AA Hunter will go in and it'll leverage Zeek's ability to go in and look at the application layer. So here we're seeing this is a TCP session, TCP 443 session, and we're saying, hey, we saw an SSL handshake here. Great. Now I know if somebody's using SSL over the port I expect to see SSL on, life is good. But if I look at these first 3 entries, this is saying it's TCP 443, but I don't know what application was using it. Well, wait a minute. Zeek understands about 55 different apps. If it doesn't recognize it, somebody's probably tunneling things. So now I need to go in and kind of take a look at what's going on there. And that's actually a pretty common technique. If I've got a C2 channel and I run it out over TCP 443, I could use SSL. Or, what I could do is just say, let me obfuscate the data. And now it looks encrypted. And since nobody pattern matches on this anyway, no one will notice. And I can just tunnel things right out. But by looking for the application layer, you can actually go in and catch that. So the other thing we give you is the ability to go in and start doing additional research. So I can go in and I can look at this and I can say, hey, what does VirusTotal tell me about that external IP? Or what does Shodan see? Or whatever the case may be. When it comes to the internal IP address, I can connect it to things like Carbon Black Response. If you're running Carbon Black Response, you can go in and you can say, hey, this IP talking to that IP, show me what application was responsible for that. We've also created a connection with Beaker, our new open source tool. Yes.
Hey, real quick, before you move off of that, the menu that you show there with copy to clipboard deep dive, that can be customized as well. So if you've got an internal tool where you keep track of assets and you want to be able to put a link in there saying, hey, tell me about this in our asset tracking system, you can modify that menu and add a new entry of your own.
Both menus, you can do that. Absolutely. Thanks for throwing that in, Bill. And actually, that's how Carbon Black Response, that's how you integrate that. You just go in and say, hey, Carbon Black Response is at this IP address. Here's the port it's using. And now that'll show up as a menu item here. So anytime you're in here doing an investigation, you can go in and you can leverage Carbon Black for that, which is kind of neat. The other thing you can go through and leverage is our tool here, Deep Dive. So what Deep Dive does is Deep Dive just goes in and looks at everything the system talked to. So this is a summary of all the communications that took place for the system going out to the internet. And I can go in and I can drill down on any of these. Any place where a system gets listed with a white IP address and the connection is in white, that's where we said, yeah, this connectivity looks pretty normal. Don't worry about this. We didn't see anything odd or suspicious about it at all. Anytime you see something here in orange, that's an indicator that, yeah, we saw something odd. It might have been beacon activity. It might have been invalid digital certificates, unique user agent, whatever the case may be. Something was odd. It isn't necessarily what caused a lot of threat points to get created, But what we're trying to do is if you want to get into the nitty gritty of what this system was doing and what may or may not be suspicious, we wanted to make that as easy to go through and dig through as possible. So we've got that here. The other cool thing you can do is you can leverage this to go in and look for folks that may have pivoted. So one of the problems with trying to detect lateral movement is false positive rate. And I've seen this with so many different tools. They go in and they look for a specific pattern on the network, and it's possible for that pattern to take place legitimately. So now you start seeing an alert going off all the time saying, warning, Will Robinson, I think I see lateral movement. And now you go in and you investigate that alert and you say, oh, yeah, no, that's false positive. Oh, gee, that was just the backup system, whatever it was. And again, you get in that mode of ignoring that alert when you see it. So if real lateral movement takes place, yeah, your tool might have detected it, but if you've already been trained to ignore that alert, you may not see it. And what we wanted to do was minimize the false positive rate. So how do you detect this without generating false positives all the time? And this is actually pretty damn easy. So imagine I go in and I look and I see this connection, and I look at it and say, oh, wait a minute, this IP address, it's been compromised. If I want to see, have any of the other internal systems been compromised as well? I can click on the external IP, I can jump into deep dive, and this will show me who's talking to it. Because when an attacker starts moving laterally, one of the first things they do is they get those systems to start talking out to the same C2 server again. This gives them redundancy. That way, if this first system, you identify it's been compromised, they don't completely lose connectivity to your network. They can get in through one of the other compromised systems. So the ability to be able to jump in here and really quick and see what internal systems talk to that IP, we've run into this in the field. So where there's one system that's beaconing like once per minute, and that beacon stands out pretty straightforwardly. So you can go in and you can catch that. And then when you pivot into the screen here and look at that external IP, there's actually 5 or 6 other systems talking to that IP. The difference is they're only beaconing like every 4 hours. So that beacon's a lot harder to detect. But by going in and kind of doing the pivot and checking it out this way, that stuff stands out pretty quickly. So that's kind of a neat feature. The other thing we just added in, and I'm going to cover this in more detail in a month. I want to do some really hardcore beaker labs because, again, we're kind of caught up in that, oh, hey, review your system logs to look for abnormalities all the time. And that just obviously doesn't work because, again, 6 months to detect attackers when they get a beachhead. So one of the things we're really pushing is start on the network and then pivot into the host logs to be able to get some context. And that's really what Beaker does. So imagine I'm in here and I say, okay, this looks suspicious to me. Actually, I got it set up on here. So I'm looking at this connection. I'm saying, oh, yeah, that looks like a perfect beacon. I don't recognize that external IP. This is looking really suspicious to me. So imagine you get a threat score like 0 to 100. Yeah, I am 85% certain this is bad. This is evil, but I'm only 85%. I don't necessarily want to raise my hand and say we need to go in incident handling mode unless I know for certain this is something that's been whacked. So one of the things that could be really helpful in figuring that out is to take a look at what was going on at the host at the time that this got generated. So I can go in and I can click this Beaker icon. And when I click the Beaker icon, that loads up our Beaker, our open source tool. And what Beaker does is Beaker looks at that internal IP talking to that external IP over that same time range we were just looking at in AA Hunter, and it extracts out what application caused that connection to take place. Okay, if Anthony Caldwell is a security person who's on a red team, great, this is probably fine. If Anthony Caldwell works in HR or sales or finance, sales finance people do not run PowerShell. We have a huge problem on our hands. If I go in here and I see nothing, one of the things I can do is very quickly change my query to say, okay, over that time period, show me all the applications on this system that was connecting to the internet. Now, if I go in and still see nothing, okay, Sysmon's not running on that system. I got to get Sysmon loaded. However, if I do that and I go in and say, oh, hey, Chrome connected to these 12 systems out on the internet, Windows Update was connecting to Microsoft.com, I see all this other activity, but I don't see what caused this connection between these two IPs. Oh, somebody's just hidden their process. somebody has hidden their process on their box, that's a serious adversary. That's somebody I got to go in and pay a lot of attention to. So again, imagine trying to find a hidden process by going through your system log. So you want to look for a process that's missing. And no, it doesn't work, right? There's no way to write a signature around that. But here, I just simply go in and say, hey, I'm seeing suspicious network traffic. Let me try and map that back to the application. If I can't map it back to the application, oh, I've got a serious security concern I need to go and pay attention to. So we've got a lot of tools here to first go in and look for that persistency of connection. And when you find that, now start doing additional research to say, okay, is there anything suspect about this internal IP? Is there anything suspect about that external IP? Is there anything suspect about the application layer that's going by? So the tool goes in and kind of runs down all of that stuff for you. So again, the idea is, how do you make a junior analyst, or how do you make somebody who's not a guru an effective threat hunter? This is where we've gone with this tool. This is why we've built it the way we have, to make this something that you can drop in any security operations center and have it work effectively. The one really marketing thing I'll kind of toss in is that we are incredibly inexpensive with this product. John and I's goal in life is not to buy huge yachts and hang out in the Caribbean. John and I's goal in life is to solve this damn 6-month problem. Let's get that time as short as possible. And when you charge hundreds of thousands of dollars for a tool, you're not going to help everybody solve that problem. So we've got our open source tool that's free. We've got our commercial tool that is incredibly inexpensive. I'll leave it at that. And the licensing is one size fits all, meaning it's a site license, meaning that if you need to monitor 5 internet connections or 1, doesn't matter, same price. Doesn't matter what the link speeds are. Doesn't matter how long you want to keep your data for. It's all just one price, and that's it. This is our commercial end to go through and kind of run through this. John, you got anything you want to add in on that?
I think you really hit what was the goal and objective that we did. And a big part of this webcast is talking about our tools. And one of the things I like to talk about when it relates to AI Hunter is we'll have people that are on this webcast that say, well, I can't afford that. And I get that. RITA is free. One of the reasons that we got the patents for RITA was to keep RITA free for the community. So there's no company that's ever going to come in and do what we're doing and basically stop us from doing it. So if you do not have the person power, or you don't have the budget, if you don't have the capability to actually implement something like AI Hunter, you can implement RITA. But I will tell you, for me doing hunt teams, AI Hunter takes my hunts from like a week down to a couple of hours tops on the network hunting side. That's really, really, really super cool. And then as Chris mentioned, we don't really have a desire to buy yachts or jets. Both Chris and I, all joking aside, are very happy with where we're at. And the other thing is we don't have VC funding. So we don't have a VC funding, like we don't have a VC firm that's demanding 90% of the pound of flesh to come towards them. And that's one of the reasons why we
and
can
the
get it there.
firstborn male child, yes.
Exactly. Which I got to be honest, it's over this past couple of weeks, I would have been happy to give my firstborn son. But that's kind of why we set it up, and that's why we make it simple. And I'm going to be completely honest, it works. We've gone head to head with a number of products that are 10, 20, actually 100 times more expensive. Yeah. And we're detecting things that they just do not pick up.
Yeah. So John's favorite thing to tell people is that we are cheaper than the sales tax on our closest competitors. And there's truth in that statement. When you look at our closest competitors, they're in the 100K plus just for a small network. We're less than 10K. So
well, and a lot of those products, okay, so let's talk about the open source side. You had Beaker up, just Beaker. We now integrate directly with your Elk stack, and we can actually tell you what that ties to on the endpoint. And right now, there's very few products that do that. I know Palo Alto does, but Palo Alto requires you to have the network package, and it requires you to have the endpoint package. But to be able to go very, very quickly from a network detect down to the host and say, this is exactly what that executable is huge. And once again, this is something that's free. And the Kibana searches that you have, this can integrate with any tool, like Carbon Black is one of our partners. It'll integrate with Beaker. It'll integrate with, I think, Graylog, I think we confirmed. It'll integrate with any of your Elk stacks because you can generate those queries and tie it into AI Hunter easily.
Thanks, dude. I am going to pass the ball to Mr. Bill Stearns.
Hey, good afternoon. This is the AI Hunter and RITA part of the presentation. We wanted to focus on how you find beacons, but I want to switch gears just a little bit to one other tool that we have that will help you understand what's on the network to start with, and that's called Passer.
And this one also, folks, is free. So while Bill's getting his screen set up, Bill, it's hard for me to describe Passer accurately, but one of the things that Bill has been working on for years is this idea of passive identification. There's this tool called P0F that, Bill, correct me if I'm wrong, but you actually took it over from Mikhail Zalewski. Is that correct? Or did you write it and then he took it over from you?
No, I have to give him about 98.5% of the credit. He really did a wonderful job of it. I helped out in a small way with helping him with some network signatures, but he really deserves all of the credit for it.
Cool. So the idea of a tool like P0F is if you look at the TCP IP header information associated with different operating systems, you can actually go through and identify what those operating systems are. So if you look at TTL values, time to live values would be indicative of operating system classes. If it's an assumed starting TTL is 64, it's more than likely a Linux or a BSD system. If you're looking at 128, it's usually a Windows computer system. 255 would be like Cisco, iOS type systems. So you have this, it's kind of important when you're looking at packet captures to be able to identify the various operating systems. And this can go all the way down to like Windows services or Windows sizes and things of that nature. But I thought P0F was dead, something we talked about in SANS 504. And then Bill sprung Passer on Chris and I. And Bill never stopped working for doing passive identification and asset inventory on networks. And now we can see Bill's screen. So Bill, I'm going to let you take it away and tell us how it works for actually identifying systems on the network.
Hey, perfect. Thank you, John. The idea is that you've got a slew of packets flying by on the network. And much like how RITA and AI Hunter want to identify beacons, Passer wants to tell you what's on the network. What kind of systems do you have? What kind of services are there? Who's scanning your network? And I wanted something that was easy to use, that would give results off of a PCAP file or off of a network interface. And we'll show you how this works in just a minute. If I can find out what devices are on my network, what operating systems are they running, what ports are open or closed, what kind of clients do I have, that gives me a collection of information that I can use when I'm trying to do threat hunting to say, oh yeah, this is this person's machine over there, or this machine's running a particular version of Apache, and oh yeah, that's outdated. But we'll take a look in just a minute. The goal is to do very simple and straightforward network discovery without a whole lot of time or money spent on it. And we'll see how that works. The one thing that Passer doesn't do well is it doesn't give you a wonderful GUI. It doesn't. It is about as close to an ugly tool as I can imagine. But as we'll see in just a minute, we're using comma-separated output. And the advantage there is that I can feed that into just about anything. If you're the kind of person that lives and breathes databases, you're going to love this. Pull the data in, manipulate it directly. If you'd rather work with a spreadsheet than anything else, you got it. Comma-separated import and you're on your way. And if you live and breathe command lines, we've got you covered there too. Let's take a look at how that works. This is the output that Passer gives you right off the bat with no tuning, no additional work needed. The second column is always the IP address in question. The first column is a two-letter code saying what type of record this is. So anything that starts with TS is a TCP server, something that's ready to accept incoming connections. Third column in that case shows the protocol and the port involved. So we have two references to Apache, one Nginx and one Apache server. And then on the third line and the fourth line, we show two DNS servers. One nice thing that I've actually stolen with permission from the Nmap group is an identification library that they use to pull out what type of server made this? So I don't know if my mouse is showing up on the screen, but if it is, this block, oh no, hold on.
Yep, your mouse is there, dude.
Perfect. So from HTTP over, I have information that Nmap's fingerprints file has helped me extract. This is running Nginx version 1.6.0, and there's an Igor Ciso EV, I think is relevant to the particular release of Nginx. But that can also get very specific Apache HTTPD version 2.4.6 running on CentOS using OpenSSL 102K with PHP 5416, all from just watching the traffic going by on the wire.
So basically, totally passive Nmap without generating any traffic at all.
Exactly right. Nmap uses that same file, and what it does is it generates a particular request, and then it says, if I see so-and-so coming back, then I believe that this is a CentOS, OpenSSL, Apache server with PHP and these version numbers. In my case, I just don't send anything. I just look for what comes back. And with a very few exceptions, this comes up with directly usable results without having to generate anything. I'm simply watching the traffic going by on the wire. So in addition to just being able to tell that port 80 is open, you get a pretty good guess that this is CentOS Linux, and you've got some version numbers to work with as well. This can help you in your analysis for RITA and AI Hunter, identifying beacons, identifying what systems are on your network, just finding an IP address that you didn't know was there. Can we find out whether this machine is running any services? You can probably do it without generating any traffic whatsoever. Last two entries, we have UDP port 53 servers that are able to respond to DNS requests. And while I mention it later, it's actually IPv6 is essentially fully supported in this. So all the addresses are written out in their full glory. That helps us sort these entries together in the future. I'll show you that in just a minute. We can see where the routers are on your network. By just looking for particular types of traffic, I can see that, for example, we have routers at FC01, FD80, blah, 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 FD80, and so on. And in the blue highlighted sections are, how do I know this? What did they send to me that makes me believe they're a router? Did I get a host unreachable from it? Did I get a neighbor advertisement, a router advertisement? Did I just get a time to live exceeded, which means that that machine is a router between myself and some other host I was trying to trace route to? So on that last example, my IP address, 172.17.0.29, was trace routing off to some other IP address. We don't see that here. But some host in the middle, 62.115.134.6, sent back a time to live exceeded. That's why I believe this is a router. In the case of a router advertisement, I get even more information. I get to see what the IPv6 network assigned to this cable is. I get to see what the DNS servers are for that network and the hop limit, which in this case is 64. So all passive. This is just Third category is clients. And this is where you get to see, in most cases, what are my machines doing to connect to the internet? So I can see that 10.0.0.41 is a TCP port 22 client, and I'm making a guess that that's SSH. Actually, no, I'm seeing the signature for SSH, and that's why I'm putting in SSH/OpenSSH there. That isn't a guess. If I don't know, I just don't put anything in the last column. The second line is a TCP port 80 or web client. So this one is making some type of HTTP connection. If you get these, UDP port 520, somebody is a RIP or Router Information Protocol client, and you're not using RIP on your network. This might be a good one to look into. Why am I allowing this traffic across my perimeter if I'm not using RIP? And likewise, if for those who remember the use of CareGen and Echo and Daytime and all the rest, These are the small services. These are the ports below about 21, where these low-numbered ports are really just kind of there for debugging and troubleshooting. But if you've actually got somebody using CareGen, that can be used in a denial of service attack. Because many of the IoT devices will actually advertise themselves over multicast DNS, I can look and see not only do I have a printer on 10.0.0.179, but I can tell it's a brother MFC J5830DW, and that now I've got a sense of what types of IoT devices are on my network as well, including somebody who snuck in an Apple TV. We'll have to go and track that one down.
I love the ability to just see like all this stuff that you probably didn't know was there and really need to kind of worry about. When you're logging like outbound stuff in your firewall, you're seeing a source IP, but that kind of blends with everything else. When you start seeing what was that system, what is it accessing, what might it have running on it, oh, that adds a whole lot more context.
It really does. And it helps you understand. If I've got, a brother printer, that's not a problem. But if I look up in my list of beacons that 10.0.0.179 is making regular outbound connections to an IP address that has nothing to do with printing or Google Print or anything else.
It's only Russia.
Exactly. I wasn't going to mention a country. No. If you see traffic that doesn't make sense, now you've got context to say, oh, this should not be happening. The same type of traffic that would be totally legitimate on a security analyst's machine can be totally malicious when it's being done by a printer or some other device on your cable. And remember, because this is totally passive, I'm watching everything that shows up. If you put me on a span or mirror port, it's going to report on everything. And that means I don't have to know what are the live addresses on my cable. What are the live machines on my cable? I don't have to have some pre-built inventory. I just get it all reported.
Hey, and Bill, 3-minute warning. We're coming up to the top of the hour.
You got it. Great. So finally, just a couple more. It will look for things like ports that you shouldn't be communicating on. Port 23 for Telnet, you shouldn't be talking on. Is somebody sending in a scan? Is somebody using NTP to send in a DDoS traffic? And is somebody scanning for SIP or voice over IP clients? These are kind of things that can also detect. Finally, we do look for MAC addresses. So I can actually associate a particular manufacturer with a MAC address and say, oh, this is likely to be an Apple machine, as well as DNS types like A, CNAME, Quad A, and PTR. I won't go and go through the demo. If you'd like to give this a try, these are the commands that I was going to run. Pick a PCAP file that's from your own network, run through this. You don't need root privilege for it. And then the CSV output file that's generated, go over with another command and take a look at what type of data you get back. The sort command simply brings all records for a given IP address together so that you can see what type of all of the different records for one IP. It runs on Linux and Mac. It does use a library called Scapy. And as I mentioned, you can use a PCAP file or listen live on an interface. There is a multi-process version in progress. It's not complete. It takes a lot of time to put it together. We'll include ASN data as well as GeoIP information. If you want, it'll even do active scanning as well. What we may do is once we close up for the hour and we've finished up any questions, I may go back and do that live demo if people want to hang around. The source repository is at activecm/passer on GitHub and also on my website. If you have questions, william.l.stearns@gmail.com. And all of our tools, you can find more reference to our open source packages on https://acm.re.
And that's activecountermeasures.com. It's just a whole lot easier to type that.
Sure is. So thank you, everybody who's taken the time today. We really do appreciate your listening in. If you've got questions and want to put them over into ACM Webcast chat, we'll be on for a little while. And if you're finished for the hour, we appreciate your time. If you want to hang out, Chris, would it make sense for me to do the demo after we finish up?
That would be a Shelby call.
That would be a Shelby call. Sounds good. Well, hey,
Yeah,
thank you, everybody.
If we have people that want to hang out to watch the demo, that'd be awesome.
There you go. You've got we respect your time.
Thank you, everybody. And if we seem like we get caught up on the questions, then yeah, Bill, go to town on the demo. Because you know me, I love watching your tools.
I did have one thing to throw in. If anyone would like another demo of AI Hunter, right, Chris? Or are we doing that where people type in
Yeah, we
demo?
can do that, definitely.
Yep. So if you type in demo in the questions window or demo inside the Active Countermeasures Discord, we'll reach out and have someone set up an appointment time to talk more about your specific use case in your organization. All right.
Sounds
so
great.
Just type in demo.
And I do have some questions that are kind of, a bit backlogged if you guys want to do like a rapid fire kind of question.
Yeah, go for it, man.
Okay. One is from Nathan, and he's asking, could Beaker be installed on top of an existing Elk instance like Security Onion?
The goal is to accommodate that. I don't know if we've tried it yet. Bill, do you know off the top of your head?
We did have one person who wrote in and asked a similar question, and I think you have to manually load some dashboard entries. I don't have instructions on how to do that by hand, but I do believe that may be possible.
Thank you. And then David is asking, does AI Hunter use open APIs to integrate with Splunk and our other enterprise tools?
So AI Hunter will send its alerts via syslog or Slack. So like Splunk will accept syslog messages. So yeah, you can just use AI Hunter to send syslog messages to Splunk that way.
Awesome, thank you. And then Raymond is asking, what category from Gartner Magic Quadrant does AI Hunter fall under?
Probably network monitoring, although I struggle with that one because network monitoring is just so generic.
Mm-hmm.
It's like saying blue. Well, wait a minute. There's lots of shades of blue. There's lots of variation, because if you kind of put us into network monitoring, so Suricata is our biggest competitor then, right? Yeah, no, not even close. Gartner, I think, is still playing catch up, but that's, I think, where we end up for now.
Okay, cool, thank you. And I have one more, and that's from Daryl, and he's asking, is RITA a next-gen security solution?
I kind of hate the next-gen label on anything. Because like back when we went through that with firewalls, everybody was like, oh, this is a next-generation firewall. What does that mean? Well, it didn't mean anything. It was still based on stateful inspection. It was still inspecting packets as they go by. They just added the -ng to the end because that made it kind of seem cool. I kind of feel like the same way. I think in this case, maybe it's more applicable because like threat hunting the network, that's not something we've been doing correctly up until like maybe the last couple of years. So that is definitely next gen.
Thank you.
And
Yeah, no,
thank you for playing moderator, Keith. Much appreciated.
Hey, no problem at all. Thanks for all the great information.
See a question, does AI Hunter only work on Zeek logs? So Zeek is our preferred data source just because, wow, it's Zeek. We will work with like NetFlow 9, but you don't get the same fidelity. One of the things you can do by using the Zeek logs is we can identify what was that user trying to get to when they ended up at that IP address. So one of the things we're starting to see is C2 servers that are sitting behind CDN networks. So if you get an attacker that's using Amazon CDN, now you see legitimate traffic going to Amazon CDN. You see the C2 channel going to it. How do you tell the difference? Well, the answer is you got to look at the query. So now if I track the query, I can see that they were trying to get to evil.com when they landed at Amazon. By seeing that, you can figure that out. you can extract that information out of Zeek. You can't get that out of NetFlow. So we'll work with NetFlow, but you're only going to get about 70% functionality.
So what I've done is I've started up Passer over in the background, and it's reading out of a PCAP file and writing its results out to a comma-separated file. So if I simply grab that file, I'm going to use sort to pull all of the entries for a given IP address together. And what I get is a bunch of DNS records, a fact that a particular machine is a DNS server. We see down here that 441.46.146 port 80 is open and ready to accept connections. We see details on NTP servers, including what their reference is, who's their parent that they work with, a whole bunch of host names, and then examples down here of a given machine and its software versions listening when it's listening on port 80. This is obviously a whole bunch of information that you can either pull into another tool or work with right on the command line. So for example, if this is, well, that's kind of interesting, but I really want to know about SMTP servers, one thing I can do is add in a filter saying, just show me lines that have TCP_25 in them, and then feed that into the same sort. And what I get out is a much shorter list of just the machines that have TCP port 25 open. If you'll notice, I didn't make the filter very clean. I never said that there couldn't be another digit after that. So if I simply clean up that filter just a little bit and say there have to be commas around it so that I don't get TCP port 250, now I get just the SMTP servers and the details about them and what software versions they're running and what their host name is. So machine 161.130.80.30 is a Windows box. It's listening on the host name umh-msxproto2.umh.edu. And it even tells you what version of Microsoft ESMTP it's running.
This is kind of cool because if I was doing a hunt and I see some weird traffic from like 1233.247.8, and I'm like, what is that system? You can go in here very quickly, just grep for that and see all the traffic that's associated with that to get a very quick answer, which is awesome because, oh my God, how often do you run across that one IP address that's doing something weird that you can't figure out what the heck is that thing?
Yep. So here are all the records that I have so far for 1233.247.8, including its MAC address, and that will help me even find out what type of hardware it is. I can look up those first 3 octets and say 00D0B7. In some cases, Passer will even fill in that this is a Dell box or an Apple box or an HP box or whatever it is. In this case, it just didn't have a record for that, so we'll have to look at that entry manually.
But we've got the PTR record pointer, which is nice. We get to see what ports are open and listening and what's actually listening on TCP 443, which is awesome. I assume that this is probably telling me that, hey, while this was running, we didn't see an inbound connection. Well, we didn't see a new connection to TCP 22. Otherwise, you would have grabbed the header from that and been able to identify what SSH was it and what our SSH server was it and what version was running.
In some cases, it will fill in the SSH server here. I'm not sure why it didn't. It might have.
Oh, I can tell you why. I can tell you why it didn't, because in the PCAP file you're analyzing, the initial connection went by before that PCAP started getting generated.
Oh, you're evil. I love it.
Yeah. Almost like I've done this before. Yes.
Never.
Yeah. So that's why you're not seeing it. But if you run Passer and then somebody SSHs to that port, you will get to see the server connection and you'll get to see what's running there.
Absolutely. What software version, in some cases, what operating system's on it. So again, the tool itself it is not the interesting part. The data that you get out of it for your own network helps you understand what's on your legitimate systems, your transient systems that are just brought in for an hour because somebody happened to be coming in for a meeting and hooked up their phone to your network, the hidden systems that you didn't know were there, the IoT devices that somebody snuck in and is watching Apple TV during lunch hour, all of the kind of things that you might just plain not see in an asset tracking system because they weren't bought by the company. So you may find things on here that you just didn't expect to see.
Yeah, and anything you see ARPing and not doing much else, oh, be afraid. Be afraid. If they're talking at layer 2 but never bother to move all the way up to layer 3, yeah, something's wrong.
Do you need to put passer on each network segment? You don't have to. You can, again, this doesn't have to be something that you run 24/7 on every cable. If you can simply do a packet capture on an existing sensor, capture half an hour's worth of traffic, and then carry that back to a central box that has passer installed, run it, you're only seeing that 1/2 hour, so it's a little bit of a limit, but it will very gladly read in PCAP files as we did in this particular short example, and it will gladly listen on live network interfaces as well. I think that's all I've got for my demos. Any other questions, Keith?
Yeah, we do have a few. It looks like Faisal is asking, can passer take a feed from a mirror port or only look at PCAP Zeek? I'm assuming both in the live demo, so I'm thinking he's got passer confused. Huh? No?
No, that's fine. That's no problem. It will gladly read from a PCAP, as we just saw. It will gladly read from a mirror port as well. So if you've got a network segment that has a mirror port set up on a switch, you take that port and feed it over to a machine running passer, and now that computer will be able to see all the traffic on the network segment. Passer will run on a non-mirrored port, and it will tell you a little bit about the network cable, but remember, it doesn't get to see traffic unless it's destined to itself, created by itself, or broadcast. So you really do want to have a mirror port if you want to be able to see everything that's going on.
And it looks like we have another passer question, which is asking can you run passer on a specific CIDR block?
To limit its input from that CIDR block, sure. Yep, you can put in a filter at the end of the command line that says I'm only interested in certain types of traffic. So for example, host 12.33.247.8, if that's all you want to know about, it will process just those packets, or a particular subnet. For example, you could say net 12.33.247 would process just that class C. I also see a reference to, hey, is there a way to do timestamp? Hold on a second. I'm going to erase this because I don't use this all that much. But I believe the option is -- timestamp. There we go. Yep. So if you want to see it with timestamps as well, you add -- timestamp to the command line, and it will send out a slightly different version.
And what's funny, Bill, is faster than you could get that set up to show, someone else already jumped in the channel and said, passer has a -- timestamp option. I use that.
I
Rep
love
out
it.
or use pandas to look at the data.
There you go. So we actually include both the seconds sent the epoch and the readable timestamp as well, if you need that information when you're doing your analysis. So these were captured in June 24th of 2002, 11:15 at night. Great. Should we wrap this up, Chris?
Yeah, so one last question, which was, and it's an AI Hunter question, is AI Hunter similar to Darktrace? Yeah, there are some overlaps between the tool. We have had a couple of folks that used to be Darktrace customers move away from Darktrace and move towards AI Hunter. So yeah, there is some overlap in the space. Today, nobody does exactly 100% what everybody else does. Everybody's got a little bit of their own niche. But yeah, there's definitely some overlap with us in AI Hunter. And with that, Shelby, we ready to call it a day?
I think we're good. Thank you, everybody, for joining us, and thank you for the 300 people who stayed for the passer demo.
We really appreciate it. Feel free to give the tool a try if you'd like. And Also take a look at RITA.
Yes, and if you would like to join us for future webcasts, please check out the Discord channel. We post them in there.
Thank you, everybody.
Thank you.